Hi Year 6, I hope you're all okay. This is Tuesday's maths lesson where we're going to be having a look at and translating shapes. Before we go into the main part of our lesson though, we have our 6 daily arithmetic questions and the 2 stretch questions if you choose to do those. So as usual, if you pause the video and have a go at these questions and then come back and watch the answers. Okay, hopefully you've had a chance to have a go at those. Question 1 then, we've got 2 with this little 3 next to it. That means 2 cubed, which if you remember means 2 times 2 times 2. So to find the answer to that, I do 2 times 2, which is 4, and then times it by 2 again, which gives me the answer 8. Okay, question 2, 1.5 times 44. It's asking me what is 1 lot of 44 plus a half of 44. So 1 lot of 44 is 44, half of 44 is 22. Add those together, gives me the answer 66. Question 3 is a BODMAS question. So for this question I would write out BODMAS. Okay, and then I'd look at which bits of BODMAS I have in this question. Well, I've got brackets and I've got a divide. Have got a subtraction, but that's in the brackets, so I'm going to deal with the brackets parts first. So in this question, I'm going to solve the brackets part first. So I'm going to do 16 take away 12, which gives me the answer 4. Then what I'm left with is 20 divided by 4. 20 divided by 4 is 5, so that's my answer. Question 4, I've got 3/4 times by 6. When I'm timesing a fraction by a whole number, it's just the top number that is going to change. That numerator changes, t for times, t for top number, so I do 3 times 6, which is 18, and my 4 on the bottom, my denominator, stays the same. Question 5, multiplying by 100, I need to move the digits 2 places to the left. Remember, when I'm multiplying, it has to go to the left. If I'm dividing, they go to the right. So I take my 0.4, and those digits need to move 2 places. So if I move my 4 1 place, it's in my 1s column, but I need to move it 2 places, so it ends up in my 10s column. So the answer we were looking for there is 40. Question 6, when I'm adding fractions, I have to have the same denominator. So I need to make both of these fractions have the same denominator. So I'm going to ask myself, what number is in both the 6 times table and in the 5 times table? So the number that I was looking for my denominator was 30. So I'm going to rewrite both of these fractions, but with a denominator of 30. So then I ask myself, what do I times 6 by to get 30? I'm timesing by 5. So I've done that on the bottom, so I've got to do the same on the top. 5 times 5 is 25. What do I times 5 by to get 30? I'm timesing by 6 this time, so I've got to do the same on the top. 3 times 6 gives me 18, and now I can add them together. 25 thirtieths, add 18 thirtieths, gives me the answer 43 thirtieths. I can leave it there, that would get me the mark in a test, or I might have written it as 1 whole 1 and 13 thirtieths. They are exactly the same and both would get you the mark. The stretch questions then. Question 1, the answer we were looking for was 198,513. And question 2, the answer we were looking for was 56. Okie dokes then, Year 6, times tables. Pause the video now and give yourself 1 minute to have a go at the times tables. Okay, we are going now into the main part of our lesson then. What I can today is I can translate shapes on a coordinate grid. So yesterday we looked at coordinates and how to describe the position of shapes using coordinates. Today we're looking at translation. So what I want you to first of all do is pause the video and think about what that word translate or translation means. Okay, hopefully you've had time to have a think about that then, Year 6. In maths, when we are talking about translation and we use the word translate, what we mean is to move. Okay, it sounds like a bit of a fancy word, but actually it just means to move something. So, on your screen you have got two dots on the coordinate grid. I've got a blue dot and a green dot. So, imagine that my blue dot is my original dot and I have then moved it to end up in the position of the green dot. So questions looking at translation might ask you how many squares it has been moved. So our keys to success are, first of all, count how many squares across it has moved, so whether that's left or right, and then count how many squares up or down it has moved. So my blue dot, to get to my green dot, it has gone one square to the right, and then it has gone 1, 2, 3 squares up. So we could say the blue circle has been translated 1 square to the right and 3 squares up. If the green dot was my original dot and it had been moved to end up as the blue dot, then it's different, isn't it? The green dot would have been translated 1 square to the left and 3 squares down. Okay, it's really important that you count both across and down when you're doing this, and take your time with it. Count really carefully. If you need to draw on your screen or on your piece of paper as you're doing it, okay, that's completely fine as well, little marks along the way. Okay, today when you go into maths.co.uk, there's two types of question you're going to come across. The first question looks a little bit like this. So we've got a triangle drawn on my coordinate grid, and they have given this corner of the triangle, this vertex of the triangle, they have given it the letter A. So this corner or this vertex is A. And they say that point A of the triangle has moved to now be at point B. Draw the new triangle. Okay, so to do this, I need to count how many squares across the shape has moved. I need to count how many squares up or down the shape has moved. And then I need to plot one vertex at a time to be able to do it. So, start with going across. So, it's point A has gone across 1, 2. Okay, it has gone across 2. And then it has gone up 2. So across 2, up 2. Okay, so I'm going to take each vertex in time and do them individually. So point A, they've already done for me. Point B, I need to do exactly the same. I need to go across 2 and up 2, because that is what they've done to A. Across 2 and up 2. So for this vertex, I'm going to go across 2, 1, 2, and up 2. So this corner is going to end up here. So I've done that corner, or that vertex, I've done that vertex, and I've got one final vertex that I need to do. So again, I need to go across 2, and I need to go up 2. So my 3 vertexes of the triangle are these 3 little crosses that I've got on the screen. I'm going to rub out my working out because that might confuse me. And then the final thing I need to do is, with a ruler, I need to join them up. Okay, so we've got one more example of that for you, Year 6. You can either have a go at drawing out the coordinates grid yourself if you want to. You could, in the folder for today's lesson, I have put a document that says coordinate grids for fluency. You could print them out if you have a printer and have a go at this question, or you could simply pause the video and have a think about where this triangle will move, and I will go through the answer in a minute. Okay, you will all have the opportunity to have a go at these questions on maths.co.uk anyway. Okay, so pause the video now, have a think or have a go at home, and then come back and watch the answer. Okay, hopefully you've had a go at this then. First of all, I would look how many across and how many up has the shape been moved. In this case, it's 1 square across, 1 square to the left, and 1, 2, 3 squares up. So I need to do that for each vertex of my triangle. So 1 vertex is there, next vertex, 1 square across and 3 up. 1, and then 1, 2, 3. Same with the final vertex, 1 square across and 3 up. Okay, and then I join them together. I've gone slightly wonky there. Okay, so that is where I was looking for my triangle to be. The second type of question that you might get when you do maths.co.uk today is something that looks a bit like this. So a triangle has been translated 2 squares up and 4 squares to the right. You need to draw the new triangle. Okay, so this time they haven't given you any of the points, but they've told you how many squares you need to move it, and you've just got to move it. So I'll do this one, and I've got another one for you to have a go at in a moment. So a triangle is translated 2 squares up and 4 squares to the right. Right, I'm going to start with this point, this vertex of the triangle. I want to go 2 squares up and 4 squares to the right. 1, 2. And 4 squares to the right. 1, 2, 3, 4. Okay, so that point has moved to there. Next, I'm going to take this vertex of the triangle. I need to go 2 squares up and 4 squares to the right. 1, 2 up, and now 4 squares to the right. 1, 2, 3, 4. And finally, I have got this third vertex here. And I need to go 2 up and 4 squares to the right. 1, 2, and then 1, 2, 3. Unfortunately, I'm going off my grid a little bit here. 4. And finally, I need to join my points together. So I've got my new triangle. Okay. Another question then, you can either have a go, as I said with the last one, on a printed coordinates grid. You could try and draw your own coordinates grid, or you can just pause the video and think about it and watch my answer in a moment. Okay, this time we've got a rectangle. It's been translated 4 squares down and 3 squares to the right. I do exactly the same. I need to plot each vertex first. So I'm going to start with this vertex. And I'm going to go 4 squares down and 3 squares to the right. 1, 2, 3, 4. And 3 squares to the right. 1, 2, 3. And I'm going to put a little cross. Next, I'm going to take this vertex. 1, 2, 3, 4, and 3 squares to the right. 1, 2, 3. Next, I'm going to take this vertex. 1, 2, 3, 4. 1, 2, 3. And the final vertex of the rectangle. 1, 2, 3, 4. 1, 2, 3. Okay, and lastly, I need to join the points together to make the new rectangle. Okay, the key to doing this year 6 and getting it right is to do each vertex or corner individually. Where children make mistakes on this is that they do one vertex and then they try to guess the other places where the other ones go. Okay, the key is do each corner as I have done. Alright then, this is the point where I would like you to have a go at maths.co.uk then. The main activity is on there. If you are choosing to do the stretch today, the stretch is linked to yesterday's work on coordinates, and you can find that in a separate document in the folder where you found this video. Once you've done your maths.co.uk, and maybe the stretch if you're choosing to have a go at it, I want you to come back to the video for the reasoning and the plenary. Okay, everybody, hopefully you got on all right on maths.co.uk. We're going to have a look at a reasoning question now then. So Dan says shape 1 has been translated 1 square down and 2 squares to the right. Charlotte says it has been translated 1 square down and 5 squares to the right. Who is correct? And what mistake might the other person have made? Okay, pause the video and have a go at writing your answer to that. Okay, hopefully you've had a go at writing your own answer. I think you probably spotted quite easily that Charlotte was correct and not Dan. But the tricky part here is, why is Charlotte correct? So, first of all, we need to answer the question, don't we? So, who is correct? We think Charlotte is correct. So Charlotte says it's been moved 1 square down and 5 squares to the right. Okay, so if I take this vertex, 1 square down and 1, 2, 3, 4, 5. So we do know that Charlotte is correct. So first of all, I'm going to say Charlotte is correct. The shape, I'm just going to change my font to be in a more appropriate size. Charlotte is correct. The shape has been translated 1 square down and 5 squares to the right. Okay, now we've got the tricky part of it. We want to work out what Dan has done wrong. So Dan said it had been translated 1 square down and 2 squares to the right. But it looks to me, if I took this one vertex here and went 1 square down and 2 squares to the right, that meets this line. It looks to me like Dan's just worked out how much across it's gone. He hasn't thought about each vertex or each corner individually. So Charlotte is correct. The shape has been translated 1 square down and 5 squares to the right. Dan is incorrect. He has not moved, or he has not translated each vertex individually. He seems to have counted the gap between the two shapes. Okay, and that's our answer for that question today. Final thing for you to have a think about for today's lesson then, Year 6. Today's plenary combines yesterday's learning with today's learning. So on my coordinate grid, I have got a shape. We want you to translate that shape 2 squares down and 1 square to the right. And then we want to know the new coordinates of that shape. So you don't need to draw this out. You can if you want to. You can print off one of those coordinate grids in the resources folder if you would like to. But we just want to know the new coordinates. So you might just be able to do it by looking at the screen. So pause the video now and have a go at this final question. Okay, hopefully you've managed to have a go at that then, Year 6. We had to go 1 square, the shape has been translated 2 squares down and 1 square to the right. So remember, we do each vertex one at a time. So 2 squares down and 1 square to the right. Okay, and the same with this one. I'm going to go 2 squares down and 1 square to the right. Next, I'm going to take this vertex. I'm going to go 2 squares down and 1 square to the right. And my final vertex is here. It looks a little bit confusing in that I've got a cross in the middle of my shape, but the new rectangle would look like this. Now we need to know the coordinates of the new rectangle. So I've got -3, 0 would be my first coordinate. I'm going to circle it once I've done them so I know I've done that one. This coordinate here, then we've got -3, 2. I'm going to circle that one because I know I've done that one. I've got 0, 0. Not -0, you can't have -0. I've got 0, 0. And my final coordinate, I've got 0, 2. Alright then, year 6. Hopefully you managed to get that tricky question at the end there. Well done for today. I'll be back with another lesson tomorrow where we're going to be looking at reflecting shapes. See you then.